So 10.2, we're going to do some calculus with parametric curve. Last time we talked about parametric curve, right? So if you define x and y as a function of t, a variable t, then the graph of this is going to be a parametric curve, right? Now, today we're going to do some calculus with it. Okay, for example, we want to find the tangent line of this parametric curve. We try to see the area under the parametric curve, etc. Okay. Now, first of all, we're going to try to divide the formula, see how the formula come out. Okay. So if x is a function of t, x equal to f of t, what is dx dt? Dx dt is the same as the derivative of this function with respect to t, right? So that is going to be f prime of t. So, right? And dy dt is the same as g prime of t. So different notation for the derivative. Okay. Now I'm going to ask you, what's dy dt? Well, dy dt by the chain rule. Okay. Suppose y is a function of x. Okay. So if we have y is a function of x and x is a function of t, then by the chain rule, dy dt is equal to what? Equal to the derivative of y with respect to x, which is dy dx, multiplied by the derivative of x with respect to t, which is dx dt, right? Yeah. Hey, Mario, you come. Nice. Oh, Mario's brother. Oh, okay. You guys are amazing. Same difference. Okay, great. Brothers. Okay. So by the chain rule, dy dt is dy dx times dx dt. Right? Okay. Now, can we solve for dy dx in this equation? Then dy dx is equal to what? Dy dt divided by dx dt. You got it. So it will be dy dt divided by dx dt. Notice that both of them have this dt down here, right? Okay. So now we have this dy dx can be expressed as dy dt over dx dt. And dy dx is kind of useful, okay? Now, if you have a curve, okay, if y is a function of x, so if you have something like this, y is a function of x, then dy dx is actually correspond to the slope of the tangent, okay? So the slope of the tangent is dy dx. When y is a function of x, okay, when y is a function x, dy dx is the slope of the tangent. Remember, the first derivative corresponds to the slope of the tangent. Okay? So now we discover the formula. The slope of the tangent of the curve dy dx is going to be dy dt over dx dt. Correcting the denominator is not 0 because you cannot divide by 0. If divide by 0 is undefined, right? Okay, so you discovered this. So next time, if I ask you to find the slope of the tangent of that parametric curve, then you just use dy dt divided by dx dt. Okay? Okay, now, what about second derivative? This is the first derivative. So what about second derivative? Remember, second derivative tell you concavity, right? So sometimes we want to look at second derivative to see the concavity. Okay. Do you remember concavity? So if second derivative is, if it's positive second derivative, then the curve is going to be what? Concave up, right? So concave up. If second derivative is negative, then the curve is going to be concave down, right? All right. So you want to see the concavity, we look at second derivative, which is take the derivative this with respect to x one more time. Okay. So we're going to differentiate the first derivative with respect to x one more time. So I just put the dy dx here and then differentiate that with respect to x. Hi Raquel. Hey, what is the custom? Oh, really? Very nice. I like it. We should take picture next. Okay. So how would this relate to this? How does this relate to the first derivative? Right. So take a look here. So this is the function. This is the function you're going to differentiate with respect to x over here. That's a derivative. So that's a function, right? This is the function you're going to differentiate with respect to x. Okay, what about this? Here says that if you differentiate this function, right? Differentiate y with respect to x, you have this. So this function is taking the place of this y. Do you agree? Right? So you just need to put this. So we place this y over here by this function, right? We can just use the same formula. When you differentiate this with respect to x, it says that it's the derivative of that with respect to t over dx dt. So we can just replace this y over here by dy dx. Okay, so we can put dy dx over here. Okay, and then differentiate with respect to t. And then down here will be the same as this one. Down here is dx dt. Okay, so differentiate this with respect to t and then over dx dt. Okay, so you just put this one here. Okay, so that will be the second derivative. Okay, this is taking the place of this. Okay. All right, so that will give you the concavity, and we can know the concavity by looking at the second derivative. There are a couple notes here that we want to point out. So if we think of the curve as being chased out by a moving particle, then dy dt and dx dt are the vertical and horizontal velocity of the particle. Okay, so what does it mean? Okay, let me draw some picture. So here is the curve, and then it's chased out by a moving particle. Okay, so what is dx dt? Dx dt, I'm sorry, dy dx is the slope of the tangent. Yes, dy dx is the slope of the tangent. Okay, so you have a tangent right here. So the slope over here is dy dx. How is it related to dy dt and dx dt? Dy dt is going to be this vertical, the vertical velocity. Okay, that's dy dt. And then the horizontal velocity is going to be dx dt. Okay, and now you can see that they're related this way. Okay, so if you project this along the vertical direction, that will be dy dt. Project along this horizontal direction, that's dx dt. So this slope over here is this. If we think about this as the velocity in this direction, that's the velocity along the vertical direction, velocity along the horizontal direction. Okay? So the slope of the tangent is the ratio of this velocity, this divided by that. All right. Okay, now the second one. There's the formula 1. Okay, which one's the formula 1? This is the formula. The dy dx equal to this. Okay. This one here, we can remember that. Let me put the formula down one more time. Okay. This formula, here you can remember by thinking about like canceling the dt, right? If you're canceling the dt and dt here, you get the dy dx. So in able to find the slope dy dx of the tangent to a parametric curve without have to eliminating the parameter t. So you don't need to find the formula with y and x together directly. You can just find dy dt and then dy by dx ct. Then you can find dy dx. Okay. Right. Providing the denominator is not so. Okay. Now, if you're looking at this, what happens if the curve has a horizontal tangent? Horizontal tangent, what will be the slope of the tangent? It will be 0. Then the numerator will be equal to 0, and the denominator is not equal to 0, right? And what about if it's a vertical tangent? The slope will be undefined. Then you will have the denominator equal to 0, okay? And the numerator does not equal to 0. Okay? All right. Okay, it's better that we see some examples so we can understand this a little bit better. Okay, let's try the first one. We try to find dy dx and the second derivative over here, for which the value of t is the curve. Well, okay, we try to find what t will have the curve concave up. Okay, but let's do one step at a time. Let's try to first find dy dx first. Okay, let's find dy dx first. Okay, how do you find? Okay, to find dy dx, how do you find dy dx? Yeah, yeah, dy dt over dx dt, right? So then we need to find dy dt and dx dt. Let's do it together. Okay. So we have y equal to we have here t plus ln of t. Okay, let's put it on the side. And then we have x equal to t minus ln of t. Let's find dy dt. Okay, let's do this together. What's dy dt? Yes, you got it. It's 1 plus 1 over t. Good job. Okay, now let's try to find dx dt. Differentiate this with respect to t is 1 minus 1 over t, right? Now, once you get this 2, you'll be able to figure out what dy dx equal to, right? So that's equal to dy dt is this. Okay. So we put 1 plus 1 over t, okay? And then dx dt is this one over here. So we put 1 minus 1 over t. Now let's try to simplify this. This is kind of like a complex fraction, right? How do you simplify complex fraction like this? We multiply. Yes, you got it, Rani. So we multiply this by up and down by the, okay, so I do a next step, okay. So let me write it the next step. So we're going to multiply this up and down by the LCD. The LCD here is this T. So times T up and down, okay. This is the LCD. So multiply that by LCD. So that will become T plus 1 over T minus 1, right? And somehow we'll think this one looks better, right? So that's dy dx. What does dy dx represent? Geometrically, that is the slope of the tangent, right? That's the slope of the tangent. Right? Now, so we finished dy dx. The second part over here asks you to find, what are we trying to find? We're trying to find this one over here, right? That's the second duality. Okay, let's do it together. Okay, so you can remember the formula. What do I put on top? dt, right? And then you put the first duality over here, right? So you're going to put the first duality, which is dy dx in here, right? And then down here will be what? dx dt. You got it, okay? Okay. All right. So that's equal to, let's put the first duality in, dt. First duality, we know that it is what? T plus 1 over t minus 1, right? And then down here is dx dt, which is what? We found that dx dt, yes, it's going to be 1 minus 1 over t. Okay? It's this one over here. dx dt is 1 minus 1 over t. Okay? All right. Now, to differentiate this, what kind of differentiation rule do we need to use? Quotient rule. Okay? Go ahead. Okay, do the quotient rule. Tell me what you get. Okay. Oh, yes. That'll be fun, right? So we use the quotient rule. Okay, tell me what you get. You simplify it, right? Very good. Okay. So the quotient rule says that you're going to square the denominator and then differentiate the top. You get 1, and then times t minus 1, and then subtracting the top is t plus 1. The duality of t minus 1 is 1, and then it's going to become negative 2t, right? It's going to become negative 2t on top, and then it's going to be t minus, oh, I'm sorry. Oh, I think let's go back, okay? It's negative 2, okay? So this t minus that, so it's negative. You got it, yeah, you're right. So it's negative 2 over t minus 1 squared, yeah. So you got that one. And then now divide by t, 1 minus this. But let's combine this, okay? Can we combine this? Okay, let's combine this. So that will be, if I use the common denominator t, that will be what? T minus 1 over 2, right? Do you agree right here? Right? So that becomes it. So I just use the common denominator t. So I got this. Okay. Now if we do the algebra, divide by this is the same as multiplied by reciprocal, right? So negative 2 t minus 1 squared, and then you times the reciprocal, so that will be t on top, and then t minus 1 down here. Simplifying this, then what do you get? Negative 2t over t minus 1 to the third power. Agree, right? But we're not going to stop here. We want to see the concavity, right? So how can we see? This is the second duality. It's supposed to help us the concavity. So we need to see when will this be. Okay, again, let me remind you. Second duality. How concavity. Okay. If the second duality is positive, then it's going to be concave up. And if it is negative, it's going to be concave down. Now, in order to see that, let's first want to see where is it concave up, right? So concave up will have the second duality to be positive. So we're going to solve. So we're going to set this negative 2t minus negative 2t over t minus 1q to be greater than 0 because we want it to be concave up. Okay. But in order to do this, we need to find out when will this be equal to 0 and when will this be undefined first. Okay? Okay, let's look at the numerator and denominator. So when will negative, how do we solve this? So negative 2t is equal to 0 when t equal to what? 0? Yeah. So we're going to look at the numerator and denominator separately. So numerator equal to 0 when t equal to 0. And then we look at the denominator. So the denominator is t minus 1q. If I set the equal to 0, then it will be undefined. And this is when t equal to 1, right? So now you have these two numbers, 0 and 1. And then remember when you do college algebra, they say in order to solve this inequality, you make a side chart, right? You can remember that, right? So let me refresh your memory. So you have the number line over here. You're going to use these two numbers from small to big to divide the number line. Okay. And then you make a side chart over here. Okay. So let's look at negative 2t. Negative 2t, what will be the side? How will the side look like? Well, it's going to be 0 over, it's going to be 0 when t equal to 0. What happens when t is greater than 0? Positive or negative? Negative. You got it. Good. So it's going to be negative here and here because this is opposite of 2t. So when t is positive, negative 2t will be negative. So it will be negative over here, okay? Because the opposite sign right here. And it's going to be positive when t is negative. Okay, good. This is the side chart. Okay. Now what about the denominator? T minus 1q. It's going to be 0 when t equal to what? 1, right? 1. Well, what happens if we substitute something bigger than 1? Say 2. 2 minus 1q, positive or negative? Positive. So it's going to be positive here and then negative here on the other side. Okay, so you get this. Now, this is the quotient of this one and this one. What happens if we have positive over negative? So it's going to be negative, right? So we know that this quotient over here is going to be negative over here. Okay, what about negative over negative? positive here. Negative over positive, negative here. But we're looking for positive, right? Because want this to be concave up. So it will be this one. Okay, this one here is the one that we're looking for. Okay, when the quotient is positive. And corresponding to this, the t is going to be from where to where? 0 to 1. Yeah, so it's going to be from 0 to 1. So when t is greater than 0 and less than 1, then this quotient will be positive and the curve will be concave up. Okay, let me write it down. So we'll say that the value, okay, maybe I just make it simple. So I will say the curve is concave up. Okay, CU means concave up. Concave up when t is greater than 0 and less than 1. Agree? Because of that. Okay. All right. Some people will say, wow, that's a lot of work, right? College algebra. Remember you guys did this kind of side chat, right? Let me say, is there another way to do this? If you use a graphing calculator, yes, you could actually do using a graphing calculator to do this. So when you use a graphing calculator or using decimal, and you can try to graph this negative 2t over t minus 1 cube. So when you graph this, then you can see the curve is going to look like this. Something like this. And then like that. And then here will be like this. And this. Okay. Okay. So you see the graph like this. Okay. So it's the f of t equals this. Okay. Now from this, we're looking for positive, right? We're looking for this to be positive. Then you see over here is from 0 to 1. It is positive over here from 0 to 1. Okay, and the rest will be negative. So if you want to use the graphing calculator to solve this, you can actually see right here. Because right here is positive. Okay. Okay. Wow, that's a lot of work, isn't it? Okay. All right. Let's just do one more example. Okay. The second example here, we try to find the point on the curve. The tangent is horizontal or vertical. And if you have a graphing device, yeah. Oh, sure. Yes, yes. Okay. Okay. What's the name of my brother? Luigi. Oh, hi, Luigi. Good question. The picture. Luigi as an L. Okay. Okay, great. The next example, we're trying to find a point on the curve where the tangent is horizontal or vertical, right? Okay. How do you get the tangent is horizontal? Yeah, dy dx is going to be equal to 0, right? Horizontal tangent. Vertical, you have dy dx will be undefined, right? Okay. Okay. And we know that dy dx is the same as dy dt over dx dt. So when you have the numerator equal to 0 and the denominator does not equal to 0, then 0 divided by a non-zero quantity, you have dy dx equal to 0, right? And how do you get undefined? Undefined over here is, how do you get undefined? When the bottom is equal to 0 and the top is not equal to 0. Okay, so those are the cases. Okay, all right. So in any case, we need to find the. Okay, let's write it down. X is E sin theta. Okay, and then here Y is E cosine theta. Let's try to find dy. Oh, now I'm not using t. I'm using what? I'm using theta. Okay, so let's change that to theta. Theta and theta. This will be theta, and this will be theta. Okay. So the variable here is theta. Okay, let's find d what? dx d theta first. Okay, what's dx d theta? Exponential function, the alpha function, exponential function. So that will be what? Yes, you got it. So that will be the exponential function itself, e to the sin theta. Let's copy that function, the exponential function. And then by the chain rule, multiply by the duality of this inner function. What's the duality of sin theta with respect to theta? Cosine theta. You got it. Good job. Okay. Now the next one. Okay, let's do the dy dt. dy d theta. I keep on saying t. The variable here is theta. So what's dy d theta? E cosine theta, because exponential function, right? With base e, right? So will be that function itself. Okay. By the chain rule, times the duality of this inner function. What's the duality of cosine theta with respect to theta? Okay. What's the duality of cosine theta with respect to theta? Negative sin theta. Yeah. Negative sin theta. Got it. Good job. Okay. Okay. Once you find this, now we can find so we can actually write down. Okay. Let's write down dy dx. Okay. So dy dx is equal to, let me erase this. It's going to be dy d theta over dx d theta. And that's equal to what? E cosine theta times negative sin theta over E sin theta times cosine theta, right? Okay, good. All right. So now we will say, when will this, let's set the numerator equal to 0, okay? When will this equal to 0? Okay, let's think about it. So E of cosine theta times negative sin theta equal to 0, okay? And then later on, we also set the denominator equal to 0, right? Okay, let's set this equal to 0. So let's just focus on solving these two equations. So basically, I'm setting the numerator equal to 0, and then I set the denominator equal to 0. Okay, and let's see what happens. Okay. So first of all, I'm going to ask you, e to the cosine theta, will that ever equal to 0? Huh? Can e of the any cannot? Yeah, because do you remember the exponential function, right? So how do you get the exponential function? It's going to be like this. E to the u, okay, this is u, it's always going to be above this. It's always going to be positive, right? So this one here is never going to be 0. Always positive, okay? Never 0. So same with this, never 0. Okay? So the only way you can get 0 over here is what? Sin theta equals 0. Good job. Okay. Good observation. So sin theta equals 0. What does theta equal to? Oh, yeah, inverse. That will be what? 0 and then what? Pi. 0 and pi. Okay. Remember sin theta, right? Sin theta look like this. It's going to be 0 here, 0 and pi, right? And remember, we're looking for yeah. So that be good enough. Okay. So theta equal to 0 and pi. Okay. So now, let's solve the other one also. Can you guys solve the other one? Cosine theta equal to 0. What does theta equal to? Pi over 2. Yeah, you got it. Good job. Okay. Theta equal to pi over 2. And also what? 3 pi over 2. Wow. Marius brother doing good. Good enough. Okay. All right. So now you see that. Okay. What do we notice that? So this one here, the numerator equal to 0 when theta equal to this, right? And the denominator equal to 0 when theta equal to this, okay? So therefore, okay, when theta equals 0 and pi, what do we get? Horizontal tangent, yeah. So we say this, therefore horizontal tangent. So horizontal tangents at theta equal to this, right? And what about when theta equal to this too? You get what? Vertical tangent at this, right? Okay. But they're looking for the point, right? They're looking for the point. So if you get theta, can you get the x and y? They're looking for the point, x and y. So how do you find this point? Plug it in, right? Theta equal to 0, x equal to what? Okay. Let's go back. Okay, let's go back here and copy this. X equal to this. Okay, let's put it down. All right. Sometimes it doesn't listen to me. Come. Okay. Okay. So x is going to be e to the sine of 0, which is going to be e to the what? Sine of 0 is 0, which is going to be 1, right? And what does y equal to? E to the cosine of 0. What's cosine of 0? Anyone? 1. Yeah, I saw you have one finger up. Okay, it's the e to the 1. Okay. All right. So you're going to have e, right? So the point you have over here is going to be 1 comma e. Okay, you're going to have horizontal tangent. Okay, and then similarly, oh my gosh, is that a flash? Oh my goodness. Okay, okay. Similarly, you're going to do the work and substitute theta equal to pi. Can you guys do the work and tell me what does x equal to? X equal to what? Y equal to what? Tell me. Okay, it's going to be 1 and then what? 1 over e? Yeah, 1 over e. So you get the point is 1 over e. So what happened here is at this 2 points, what kind of the tangent? Horizontal tangent we got. Okay. Now on the other one, you can do a similar thing. You substitute theta equal to half of 2. And can you guys work on this? Tell me what does x equal to, y equal to? Oh, I'm sorry. It's not 1. Okay, what does x equal to? What does y equal to? I hear you say that E1. Yes. So that will be E and that will be 1. And then this one here will be what? 1 over E and 1. Yeah, we got it. So here E1 and here 1 over E1. Then you're going to get, at this 2 points, you're going to get vertical tangent. So that's how you got it. Okay. It's a lot of work, isn't it? Okay. I have a picture of this, but let me save this. So that's how we do it. Okay. Do you guys want to take a break? Let's take a 10-minute break and we come back. Okay. All right. I'm going to pause the recording. So next, we're going to talk about the arc length. Okay. The formula for arc length. Do you guys remember arc length? Remember, the formula for arc length is the integral of the differential arc length, right? And you guys were doing a very good job. Remember this. When y is a function of x, then this differential arc length dx is going to be expressed as, put the dx outside, and then the here inside here will be what? dy dx, okay? And then square. And then 1 plus that, and then we take the square root, right? And then if x here is a function of y, then we put a dy outside, then here will be what? dx dy, right? But today, we have parametric curve. So for parametric curve, x and y are function of t, right? X is f of t, y is g of t. Then how do you express this dx? It's going to be like this. It's the square root, let me make it larger, is the square root of dx dt square plus dy dt square, and then here dt. Okay? So you see the similarity between these three, right? There's dt here, they have dt and dt. Actually, if you think about you square this and distribute inside the square root, you all get dx square plus dy square inside the square root, right? So the arc length function for parametric curve is going to be like this. It's the integral of the differential arc length, and the differential arc length will be using this formula. Okay, dx dt square plus dy dt square, square root, and then here dt. Okay, and when t go from alpha to beta, then you will put here dt here, and then t go from alpha to beta. So when the curve is described by x equal to f of t, y equal to g of t, and t go from alpha to beta, and if the dx dt dy dt are continuous, and the curve is traverse excessive 1, then this will be the arc length. Okay, so that will be the arc length over here. Okay, let's try some examples. We know the formula. Okay, now this one here is it's kind of like a star, right? Like a star in the sky. Okay, and we try to find the total length of this. So it's called archoid. Okay, and but looking at this, we found some symmetry, right? Isn't it this, and this, and this? They all have the same arc length, right? So how about we just find this and we multiply this by 4, we'll get the total arc length, right? Okay. So from here, the data is going to be equal to 0. When data equals 0, we start at this point, when data equal to power 2 we end at this point. So we know data go from 0 to power 2, from here to here. Okay. Now what do you do? Okay. So in order to do that, remember when. Okay, let me write down the formula, right? How do you find this odd over here? Okay, this odd over here equal to the integral of the differential odd length, right? Okay, and that's equal to integral. For the dx over here, what they're going to replace by? Square root of, and if I put the dt outside, right? Then what should I put here? dx dt square, and then adding dy dt square, right? And then t, oh, they're using the data. Okay, I keep on saying t. Okay, this time the variable here is data, d data. Okay, so they use data here, data here. Data go from what to what? Data go from 0 to power 2. Yes, 0 here, and then pi over 2 here. Okay, as soon as you can recognize this integral, the rest will be just routine. Okay, it's very important to separate the integral. Okay, so this is for this art. Okay, so we do that. Now, in order to do this, we need to first find what? dx d data and dy d data. Okay, let's do that. So what is, okay, let's put down what's x equal to. Let me copy that. X equal to this. We do it over here. X equal to this. So what is dx d data? Dx d data is equal to, remember the a here is a constant, right? Okay, so the a would just a constant multiple, so it's here. The derivative, yes. Yes, the chain rule, the outer function for this one here is the q function, right? So when you take the derivative of the q function, so you get 3 times whatever inside to the second power, and whatever inside there, this is the cosine of data. Okay, cosine of data. Okay. So that's all the outer. Okay, and then now you times the derivative of this in the function, which is cosine data. What's the derivative of cosine data? Negative sine data, right? We're done with this. So this is what dx d data equal to. Now I'm going to ask you guys to find dy d data, okay, by yourself. Okay, and take a minute to work on that. Tell me what you get. Okay, Tony, you got it? What do you get? 8 times 3 times cosine data. Yes, you got it. Okay. Okay, good job. So now all we have to do is we're going to substitute the dx d data, dy d data, and we're going to plug it in here, right? So we're going to plug in over here, right? Okay. Now to do that, now we're going to have this form, right? You actually get to this step right here. Okay. Wow, there's a lot to establish. Mario, that's a big jump. Yeah. So, how do you get this? Let's do it step by step. Okay, let's write it down. Okay. Remember the symmetry, right? So you have this 4. Okay, remember how do you get the 4 right here? Why is it 4? Because the 4 arcs right here are equal length, right? So you have 4 of them, right? We have 1, 2, 3, 4, 4 of them. So that's why you have this 4 over here, okay? And then, okay, let me just write that. So the total arc length, okay, let me get it step by step, okay? total partner is equal to 4 of this, 4 of this, right? 4 times this one, right? Okay. So that will be equal to 4 times the integral. Let's do it right here. Okay, and then this is the square root. Let me erase this one right here. And we put the dt outside. dx dt is 3. Okay, let's put it up here. It's going to be 3a cosine of square theta. I see how you guys good. And then times negative sine theta. And then we're going to square this, right? Okay, square this. Okay, that's for dx theta square. And then we're going to add, okay, we're going to add which one? We're going to add the square of dy d theta. Then we're going to copy the dy d theta there. So that is 3a sine square theta cosine theta, right? Okay. Now t go from what to what? Oh, I'm sorry. Keep on saying t. That's theta. Okay. That's theta. Theta go from what to what? 0 to the power 2. Yes, she said. Okay, good. Now, not too bad now. Okay. Now after that, if you square this, what's the square of this? 9a squared cosine to the 4 power, right? And then when you square here, the negative sign doesn't matter, right? Then you have sine square. Okay. So isn't this the same as, isn't this one here the same as this one? Same as that one, okay? Right? Okay. Maybe I should write it bigger so you can see better. Okay, so let me just write it down. Equal to 4 integral square root. Here will be d theta, and this will be 9a squared cosine to the 4 power, and then sine square theta. And some people say, well, that's a lot, yeah? Okay. Maybe I'll provide you with the note, okay? When I go home, I put up the note for this one so you can see better, okay? All right, and then adding, what's the square of this one? 9a squared sine to the what power? 4 power, and then cosine square theta, right? Okay, and then theta go from 0 to power 2. Okay, good. All right. I'm sorry I had to put you through this. There's a lot of calculation. Okay, but if we're looking at this, right, then what do you see about this common factor, 9a squared? Can I take it out? Yeah, this is all under the square root, okay? So we can take it out. And what's the square root of 9a squared? You're going to get 3a, right? Okay, good. So we're going to get 3a. We'll put it outside. Okay, and inside the square root, right here, you're going to get, can we take out some common factors? This one and this one, what's the common factor? Isn't that, yeah, cosine square, sine square, right? Yeah, you got it, okay. So the common factor here will be cosine square, sine square. Okay, take it out. And then we will have, okay, so what do we have here? You have, if you take out cosine square, I have another cosine square left, right? And then adding, and for that one we have sine square left, right? Okay, and there's a d theta. Theta go from 0 to power 2. Now here we can, what happened to this? Can I ask you what happened to cosine square plus sine square theta? That's going to be 1. Yes, you got it. Okay. So now what happened to 4 times 3a? Because the 3a doesn't depend on data. So it's a constant multiple, we can bring it in front. So that will become what? 12a, right? Okay, the integral. And then here is 0 to power 2. Okay, what is the square root of cosine squared times sine squared? Yeah, cosine times sine. Yeah, cosine data times sine data. Because this is data here is at the first quadrant. Both of them are positive. So you don't have to worry about to put the absolute value here, right? Okay, good. So and then d data. Hey, now come to our trick. Please remember when you integrate this cosine times sine, what would you like to do? How do you integrate? You can use the UV, not UV. Remember, this is actually cosine to the r power, right? Sine to the r power. You can actually use the safe method, right? So, but however, there's an easy way to do this one here. Remember, this kind of remind you of the double angle formula, right? Do you remember the double angle formula? It is this. This is the double angle formula. Okay. Sine of 2 data is 2 sine data, cosine data. So this actually become what? According to this double angle formula, this is half of it, right? So this will be what? 1/2 sine of what? 2 data. Yes, very good. Now we're almost there. Okay, you guys are doing well. So this will be 12a. Okay, and then the over 2. Let's put the over 2 over here. Okay, let's find anti-duality of sine of 2 data. What's anti-duality of sine of 2 data? Anti-duality that is negative cosine of 2 data, but then divide by 2. Yes, you got it. Now we just need to evaluate this from 0 to power 2. And finally, and if you do the algebra, that is going to equal to 6a. Okay? All right. And question, Tony? Which part? Which part is the one that you have questioned?
So I want to know how you are not directly apply for the user. The side, no, the side delta comes from the delta. I mean, the directly apply for the user.
So you let u equal to, oh yeah, you can use user.
Okay.
You can also use user, but this will be faster.
Oh.
This will be faster. So this will be okay? This will be fast. Yeah, right. So, and then you substitute that in, and put out to be 6a. So the total arc length for that is 6a, right? Wow, this is a good review for integration technique, okay? All right. Last topic over here, okay? Last topic, isn't it exciting? Okay. So the last topic here will be surface area. Do you guys remember the surface area formula? Do you guys remember when it rotates the curve about the x-axis, then the surface of revolution on the side is going to be what? You can remember? It's going to be 2 pi. So you put a point here, x comma y, and then think about the circumference of this circle, right? What's the circumference of this circle? 2 pi r, well, what is r in this case? Y, so 2 pi y, okay? And then here will be dx. Wait, how do you, y is this one? Okay, remember you have this, okay? So each slide here is kind of like something like this, right? So if you chop this up into small band, then each small band like this. And remember last time we talked about the formula for this is going to be the circumference of that is going to be 2 pi r. And then times this one over here. That is dx, the differential arc length. Okay, times dx over here. That will give you the area. Okay, to give you this area over here. Okay, for each band. So now you add up all those bands. Then you have 2 pi. The circumference here will be 2 pi. This is the same as 2 pi r. And then this part over here is the dx, the differential arc length over here. Okay, and then that will be the formula for that. Okay, so remember, this is the circumference of circle when you rotate, and this part here is the differential arc length dx. Now, if the r is rotate about the y-axis, then the circumference of circle is going to become what? 2 pi. What is the r in this case now? X. Yeah. At that time, the r here corresponds to the x coordinate at this point, so 2 pi x. But then this is the differential arc length. Okay, the sum. And the t here goes from alpha to beta. So that's the formula. Okay. So it kind of relates to what you have learned in the past. Okay, that's the surface area. Circumference here, and then this is the differential arc length, this part right here. How about we try one example? And after this example, we can go home. Okay. Looks like this example is how long? Oh, not too long. Okay. Alright, so let's try to set up an integral represent the area of the surface obtained by rotating this curve about the x-axis. Do I have a picture here? Oh, it doesn't have a picture. Next time I put a picture, okay? But you don't need to have a picture in order to do this, okay? Let's do it together. Okay, it looks kind of scary at first, but once we put it together, it's not too bad. Okay, so we try to find the surface area. Okay, let's call that S. Okay, do you guys remember what was the formula? Right, it's the integral, and then this will be, well, it is rotating about the x-axis. Let's think about it. So when you rotate about the x-axis, okay, so here is the curve, like this. So you label this point, okay, doesn't matter how it looks like, so it's x comma y, okay. So rotate about the x-axis. So that will be the circumference of the circle, of this circle, okay. And then this part over here will be dx. Okay. So what's the circumference of this circle? 2 pi what? 2 pi y. Yes, you got it. 2 pi y. Okay. And then now I don't put any upper and lower limit over here. Okay. I need to decide what do I put for dx, and then I put upper and lower limit. Okay. Now that's equal to, I'm going to still put the 2 pi over here, 2 pi y. Okay. For the dx over here, remember this is parametric curve, right? So we're going to put the dt outside. What should you put inside here? dx dt, right? Square, adding what? dy dt square, right? And t go from what to what? What does it say here? 0 to power 2. Yes, you got it. So it's 0 here to power 2 over here. So you set up, once you set this up, it's actually not bad, right? Okay. Now that's equal to, at this time, we need to figure out, let's pause a moment to think about it. In order to do this, we need to find dx dt, right? So over here, what do we have? We have x equal to sine of t, right? So what is dx dt? cosine of t. Yeah, you got it. Okay. And we also have y is sine of 2t. So what's dy dt? Yeah, 2 cosine of 2t. You got it. Good job. Okay. Now we're going to put this back, right? So we're going to put this inside. And let's continue with the surface area. So I still have this 2 pi for the, now when you do that, remember the y over here, right? This y over here, you need to express in terms of t because this is the integral with respect to t. So how do you express this y in terms of t? Y equal to what? Sine of 2t. So we just put sine of 2t. This is the y. Okay. And then we have this square root of cosine t square, right? Adding the square of 2 cosine of 2t. And then we square this. And then we put the dt outside. We go from 0 to power 2. Okay. I think the most important part is you know how to set up this integral. Okay. Because nowadays there are so many things that the calculator and computer can do. But setting up the integral is actually the most important part. Okay. So once you have this, okay, let's think about it. Let's do the algebra. Okay, we can do it. Okay. Cosine cosine. Let me write it down. So let's put out the 2 pi outside. Okay, let's put out the 2 pi outside. This is a constant multiple. And then integral over here. And then we have this sine of 2t. And then we have this. So what do we have here? Square root of, it's the same thing. Cosine square t. And then plus, this is will be 4 cosine square of 2t. And then here we put a dt. You go from 0 to power 2. Okay. That will be a little bit complicated. Now, since you have done the most important step to set up the integral, right? Then you can just use the calculator. Okay. Use the calculator to do the integral. Okay. This one here is very hard to find the integral. Okay, so the answer over here is going to be x1 to x4. Okay, you can do that using a calculator. But you're human, you do the most important step is to set up the integral. Okay.